Hi, so in this video, uh, we will try some functions to solve the problems. So, functions, now we have used functions earlier in Python, for example, print function, an input function, and int and float functions. Similarly, we can define our own function in Python as well. And as we discussed in the class, the syntax is the word def and the function name, and we can have few parameters to separate and comma as a separator. Then we have this multi-line comment to describe the purpose of the function. Then comes the actual function, the code, and finally we leave two blank lines. So here is an example for defining a passcode. This is a code we saw earlier to check if the password is valid, and over here, so we have to write the function check passcode, which takes only one parameter passcode. And the logic we saw earlier, if the passcode has 8 or 9 digits, then we return secure. If it has a 4, 5, 6 or 7 digits, we return insecure. And if it is otherwise, we return invalid. The one thing to note is that this function is not printing anything, and also there is no input. We are just passing the parameter, and this function will return something. But of course, in an example, when we are using the function, there we need the input and we also need to print. Now let's implement this function and see how it works. So we open our Python, we open a new one, file new, and we save it, and I call it A4 sample. Okay, so in this we need to define our function. So word def, and the function name is check passcode. Close this one. Okay, so I can write here check passcode. I can pass any parameter. I'm passing parameters as passcode as well. And now I make these comments. This is the comment. So I will write down the purpose. You can describe this. So it checks the given passcode for secure, insecure, and invalid conditions. And passcode is the parameter to check, and it returns a string representing secure, insecure, or invalid. Now here comes the body. So similar logic earlier, so we can check. So we see if passcode is less than, if it is 3 digits, or passcode is more than, greater or equal to 9 digits. So 3, 6, 9. So this is the smallest 10-digit number. So we know that. So if it's more than 9 digits, it is invalid. So 10 digits. So this is a 10-digit number. And if it is less than, so it is a 3-digit. So in that case, we can say our result or whatever. So in this case, result is invalid. And in the elif passcode, now if it is greater than, it is 8 and 9 digits are secure. So these are 4 digits, 5, 6, 7, 8. These are the 8 digits, 4 and 4. So this is the smallest 8-digit number. So 8 digit is also okay. So if it is greater or equal to these 8 digits, then I can say result equal to secure. And all other cases, result is insecure. So these are the less than 3 digits, I mean less than 4 digits, it means 3 digits, or greater or equal to 10 digits. That will be invalid. If it's greater than or equal to these 8 digits, it means 8 or 9, it is secure, otherwise it is insecure. So we get all these combinations of result, and afterwards we return the result. Now we leave 2 blank lines. Now the function is defined, but we need to check it. So we can say some code is equal to input enter passcode, and then we can say print check passcode, and we give our code to it, and we run it. So it says enter passcode. If I say 999, it says invalid. Let me also enter some space here. Now if I enter 1000, it will enter insecure because it is 4 digit. And if I enter 99999, so these are 6 digits, 7, 8 digits. It is secure. So it is working. And I can even give it some more examples just to check if it is. So one is using the user input, or I can print, say, I can say print, can give value myself some code equal to, let's say 1000, the lowest 4 digit, and I can print some code and check passcode, some code. So the first one I'm getting the input, and second one I'm doing it using this logic. And to try more cases, I can copy paste and try more examples. For example, these are 4 digit, 5, 6 digit. This is the 4 digit. This is the 5 digit. And this is a 6 digit. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 2, 3, 4, 5, 6 digit. Then I can try 7 digit. 1, 2, 3, 4, 5, 6, 7. I can try 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. and I can try 9 digits, 1 2 3 4 5 6 7 8 9, and I can try 10 digits as well. So let me run it. So 1 2 3 4 5 6 7 8 9 0. Now let's run all these cases. This first is still the old one. Okay, so the first one is invalid, and here are all the remaining examples, and we can check it if it is correct or not. So we can say this 4 is insecure, 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 insecure. These are 8 digits secure, 9 is also secure, 10 will again become invalid. This is a nice example, and I can even check it one more. Now, as you can see, we don't even need to get user input. We can, but for testing our code, I can get one more example. I can even just replace it. Can say 1 2 3 1 2, and I can even have a single digit. So I can see one invalid. These are all invalid, and now these are valid. So it is working. As you can see, here is my function, some comments, here's the code, and now here I'm using my function. Similarly, I can define the second function. The second function, for example, let's try this one to check the date. And check the date, I need to find the leap year function I can use, and I can also use this check date. So let's do it. So I can say define say is leap year. I give any year, and I can check it if it is a leap year or not. You can write the comments here. Checks if the given year is a leap year. Returns boolean true if it is a leap year, false otherwise false. Okay, so how to symbol logic we saw earlier. You can say leap year is equal to year, check if it divides by 0, it is a leap year. However, leap year is equal to leap year, but it should not be divisible. It should 100 should not be equal to 0. So it is divisible by 4, but not divisible by 100. However, if it is divisible by 400, then it is again a leap year. make sure you see the difference. This is and it is divisible by 4 and not divisible by 100. For example, 1900 is divisible by 4 and not by 100, so 1900 is not a leap year because it is divisible. But if we say, for example, 2008, it is divisible by 4 but not divisible by 100, so 2008 is a leap year. But 2000 in this check is not a leap year because it is not divisible by 100, but then we make it leap year again because it is divisible by 400, and then we return at the end leap year. We can test our code as well, see if it is working. I can say year is equal to, let's say, 1900, and I can say print year and is leap year, and then I can say year is equal to 2000 and print year and is leap year. I can say year is equal to 2016 and year is a leap year, and then I can have a regular 2018 and year is a leap year. Let's see all these values. There's some problem, typo LEY, let's fix it. Okay, so it is false, it is true, so it is working, so leap year is working correctly. So now we need our other function to check if date is valid, check date. I define the other function here. So define check date and have year, month and day. Again comments. Now we'll write here. You can write the comments. Check the date is valid. You can write the more details here. Now, one thing you to note that here this is a function, so anyone who will call the function will provide these values. So these values are given to us. So now we have to check if it is okay, and our logic is, so year, if year must be between 1900 and 2018 inclusive, so less than 1900 and more than 2018, it is invalid year. So let's take care of the year. So you can initially our result could be empty, so we can check if year is less than 1900 or year is greater than 2018, then result equal to result plus invalid year. So we enter that message to the string. Now let's check the month. If month is less than 1 or month is greater than 12, then we can say result equal to result plus invalid month. So we are not printing it, rather we are just saving it to this our result. So if both year and month are invalid, initially result is empty string. If year is enters and the year is invalid, so result will become invalid year. This empty string. And if month is also invalid, so it is concatenated, it is combined both previous result and this. Now we check the days. If day is less than 1 or day is greater than 31, then it is also invalid. These are the common days. Now we have to check the days for 30 and leap year. So Elif, so here day is now between 1 and 31. So check it. Elif month. If month is 2, then we need to check if it's leap year. If it is leap year and day is greater than 29, so result is equal to 0 plus invalid day. Move into Elif. Leap year. If it is not leap year and day is greater than 28, then in that case also invalid day. So if it is a leap year, then it can't be more than 29. 29 is fine. But if it is not a leap year, it can't be more than 28. Let's check the other months. Elif month equal to, now we have to check when it is 30 or 31. So we know for these April, June, September, November, it is 30, and all other months are 31. So 4, 6, 9 and 10, 11. You can say a month equal to 4, or month is equal to 4, or 6, or 9, 11. In that case, if day is more than 30, result equal to result plus invalid day. Else day is fine, or it can't be more than 31. So, and then we don't forget to return our result. As you can see, there is no input and there is no printing. We get the input from here and we return the result here. Now let's check it. So if I say print, let's say my year is 20, year is 1899 and month is 13, and day is 32. All are wrong, so it should print all wrong. And I say check date. This I'm just printing so I can get the message, and I can also pass the same thing here. So it says invalid year, invalid month, invalid day, which is what is correct. So I can try more example. Since I'm copying it twice, it may be inconsistent, or I can just type it here. Year equal to 1899, month equal to 13, day equal to 32. And then I can replace these with those variables: year, month, day. Year, month, day. Okay. Now if I try different things, now the other case is I make my day valid maybe. Now I make month also valid, and third one I make year also valid. So over here it did not give any message. It is empty string. In that case it was, what does the requirement says? We will return none. Returns invalid day. Yeah, it's fine here. I mean, it's not returning anything, but we can return none in that case. An empty string, okay, that's fine. We can also check the leap year case here. So if I enter leap year 2000, month is 2 and 29, should be okay. Yeah, this is fine. And if I make it 1900, it should not be allowed. Yes, invalid day, so it is working correctly. So this is how we solve these problems that we get input output. Now let's see the third one regarding tennis scoring. So here our function is check winner, and we can do the similar thing. So define check winner, and we give xy values, and this function determines the winner where x and y are the coordinates. Returns the returns the winner, player 1, player 2, or none. Yeah, score a point if any. So in that case we can check it. So here is the logic. Remember, if x is 50, this half and greater, so we can check it. If x is less than 50, it means over here display one plate if x is less than 50. So if ball goes over here or over here or over here in these three cases, then player 2 loses and player 1 gets a point. If x is less than 50, and x is less than 50, so if y, so if x is less than 0, or y is less than 0, or y is greater than 60. In all these three cases, result equal to player 1 gets the point because it went outside. X is less than 0, y is less than 0, y is greater than 60. In all these three cases, player 1 gets the point. And if it is not in this case, then result is none. Nobody gets the point. Else part, so it is not less than 0. So we can see if x is greater than 100. So it is here, x is greater than 100, or y is less than 0, or y is greater than 60. Result is equal to player 2, else nobody is the winner and game continues. And now we return the result. So now let's check it. So let's say x is equal to -5 and y is equal to 30. So I can say print x comma y and check winner, where I give the value, and here player 1 is the winner. Let's say -5 and 30, so it is over here. So player 2 threw the ball outside, so player 1 gets a point, which is correct. So let's verify the other cases also. So when x is greater than 0, maybe x is 20, 25 in the middle, but y is less than 0, y is -5. The other case will be when x is 25 but y becomes more than 60, 70, 25 is not up. And then the fourth case, when it is not outside 25. Okay, so this is player 1, this is in the middle game, continues. I can get the similar cases. Can copy them. And I can do. So now X is, I want to make it further, make it 105. So that is outside the boundary. And this one is, I can make it somewhere in the center, maybe 75, 75, and this is 75. The same is when these three player 1 wins, this game continues, nobody's ahead. Here player 2 wins in these three cases, which is more down the x-axis, less than y-axis, greater than the y-axis. Okay, so you got the idea. So we define the function. Here we define the function, and here we test it. Right now I just gave the value x and y here, but we can also get from the user input. It will take long time to get all these user input values, so I just wrote the code over here. Okay, so now we can stop it.